Let's solve the third problem for section number 12.5. So we have a lighthouse right here that rotates with a constant velocity of 4 radians. This is velocity. This is theta dot, 4 radians per second. The light is projected to a straight wall. This is the wall, right? Let's fix it, the wall. And is 100 meters away from the lighthouse. That is a constant distance. When it rotates, it projects the light, and the light is moving along that wall. And we want to find the velocity and acceleration of the projected light over the wall when theta, with this angle, is 45 degrees from the perpendicular distance to that wall. So let's do our solution, right? We have to, first of all, you have to put a coordinate system. So we do our coordinate system right here, x and y. And we know that our position, we can call the vector of position will be this one right here, will be xi plus yj, or as a magnitude, x squared plus y squared. We know that y is 100 meters and is a constant. And x, what is our x? So our x will be this distance right here. We are not given our data in terms of x, but in terms of theta. So what we can do is find our x in terms of theta and what we are given, which is 100. So we know that the tangent of theta is x over y. So our x is actually y tangent of theta. And y we know, let me write that to get more space, is 100 tangent of theta. For 45 degrees, then we know that x is equals to 100 tangent of 45. And the tangent of 45, we know that is 1, so our x is 100 meters. Which makes sense because if we have 45 degrees here and we have 100 meters here, then we have 100 meters here. So we know that for 45 degrees, our light is projected right here 100 meters from our y-axis. Let's talk now about our velocity. The same as the position, our velocity will be, in terms of a vector, x dot plus y dot. But we know that our y never changes, so we know that our velocity is 0 because our distance is constant. Then we have to find x dot. We do have x, so it will be the time derivative of this expression right here. That will be 100 secant squared dot. And it's very important that to understand that we are not deriving respect to theta, we are deriving respect to time. So we always have to put the internal derivative of theta respect to time. So that will do theta respect to time. Our x dot will be 100 secant squared theta times theta dot. If we want to evaluate that in 45 degrees, then we can say that that x dot will be 100 times secant squared 45 degrees. And we are given the velocity for that 45 degrees. Theta dot is 4 radians per second. And since it's a constant velocity, it's the velocity for 45 degrees as well. So we can say here that is 4. That leads us to our value of the velocity in x, which is equals to 800 meters per second. And finally, we need to find, this was the position, velocity, and acceleration. The acceleration will be the second derivative of x plus the second derivative of y. We know that the second derivative is 0 because we have a constant position, right? A constant velocity, and then we don't have acceleration in y because the lighthouse is not going away from the wall. So then we have to find the second derivative of the position, which is the second derivative of the expression that I have here, or the first derivative of what I already got, which is this expression right here. And then here we know that this is the multiplication of two variables, both depend on time. So we get 100 is one constant, so the derivative of the secant square is 2 times secant square times tangent of theta times the internal derivative, we cannot forget, times that theta dot, so that gives me a theta dot square, plus the derivative of second term times the first, so it will give me secant square times theta 2 dots. And we want to evaluate that term, that expression, for 45 degrees. And we know that the velocity, they tell us that this is a constant velocity. So we know that theta 2 dots is equal to 0. So this is equal to 0. Then we have that the expression for 45 degrees will be 100 times 2 secant square of 45 degrees times tangent of 45 degrees times the velocity square, and that gives me a value of 6,400 meters per second square. We got everything. Let me put just the results of y in boxes so that we know that we have x dot and x2 dots, y dot and y2 dots. So we got the values for our position, our velocity, and our acceleration.